Let's continue our study of energy and do some math problems. Let's discuss how energy is measured. Energy is measured with an instrument called a calorimeter. The calorimeter is shown below, right here. It's a coffee cup for the insulation with water, a reaction that takes place in the water, and a thermometer that records change in temperature. You get the initial temperature and the final temperature, as well as the mass of the water, and it can tell you how much heat is being produced or released, or absorbed. Calorimetry in and of itself is the study of heat flow and measurement, hence the name calorimeter for the instrument. Let's talk a few key terms. We have something called specific heat. Specific heat is defined as the amount of heat energy needed to raise 1 gram of a substance by 1 degree Celsius. Because it is only raising 1 gram of whatever the substance is, these are constants. So these are constants, which means they are numbers that do not change. They are always used for a specific substance. Here, we're only going to be focused on water. So the specific heat of water is 4.184. And it has some funky units, but we'll talk about those on the next slide. Joules per gram degrees Celsius. The symbol for specific heat is a lowercase c. We also have something called a calorie. A calorie is the energy needed to raise the temperature of 1 gram of water 1 degree Celsius. Not sure why this says through. It should really say by 1 degree Celsius. So kind of notice that it's the exact same definition pretty much for specific heat, which is cool, except that it's water specific. And also notice that 1 calorie equals 4.18 joules, where the specific heat value for water was also 4.18. In case you're confused about what a joule is, it is the SI unit for energy. Very similar to how grams is the unit for mass. And then we have something called a food calorie, which is actually 1,000 real calories. So all those diets that say that you're consuming 2,000 calories a day are actually based on a real 2 million calorie diet. I'm really glad they don't have it set up like that, because I would be very sad personally. Let's calculate some calories, okay? From the previous slide, we wrote down that 1 food calorie is 1,000 calories, so it's 1 kilocalorie. And we have some constant values here, and you can actually use these values to determine if the food products that you're eating are telling you the truth about the calorie count. So for every 1 gram of protein, it's 4 calories. For every 1 gram of carbs, it's also 4. And for every 1 gram of fat, it's 9. So let's go through and do this example problem. It says how many calories, capital C for food, are found in 1 banana if it has 25 grams of carbs, 2 grams of protein, and no fat. So I'm going to very simply take my 25 grams of carbs times 4 from above, and I'm going to add that to my 2 grams of protein, also times 4, and I'm going to add that to 0 grams of fat times 9. Okay, so 100 plus 8. If you need to do that math in advance, that's fine, or in pieces. And overall, we get 108. And you have 2 options. You can label the unit capital CAL or as kcals. Okay, so now using those same given constants above, try the practice problem. Please pause the video as you do that. Please check your answer. You should have come up with about 156 kilocalories. 10 times 4 for protein, 12 times 9 for fat, and 2 times 4 for carbs. Let's move on. Now we're going to actually calculate heat energy instead of calories for food. The equation we're going to use is Q equals MC delta T. Q is our heat energy, which is going to be joules for the unit there. M is the mass, it's going to be grams. And C is the specific heat, joules per gram degrees Celsius. And water's specific heat, as a reminder, is 4.184. Delta T, the delta means change, and of course T is temperature. We're always going to take the final given temperature minus the initial. It's okay if it ends up negative. And then, of course, the unit is degrees Celsius. Okay. I like to use a triangle, very similar to the density triangle for these problems. Q can go on top over the MC delta T. And then it would work the same way. Whatever you're looking for, you would cover up and then solve based on what's left. So in this example problem, it says how much heat is heat energy, let's label that as Q, is released when 50 grams, we know that's a mass, of water increases in temperature from 50 degrees to 76 degrees. So our first temperature is our initial, our second temperature is our final. Okay, and you'll notice specific heat is missing. That's because it's water. So anytime that it says of water, you know that your C value in your equation is 4.184. So I like to do the math for the temperature first to get that out of the way. So I'm going to take TF minus TI first, and I get 26 degrees Celsius. Then I'm going to plug them into my equation. Q equals the mass of 50 times water's known specific heat constant. Okay, I have to kind of go back here because I was looking at the wrong answer to one of the problems. When you multiply these numbers together, you do not get 56,000. You actually get closer to 5,400. I was looking at the next PowerPoint slide, my fault. So we have 5,439 joules, and then we would round this down to 5,000 joules because we only want one significant figure. Again, sorry about that. Let's run back through this problem. So you would take the mass of 50 times the specific heat of water times the change in temperature to get your answer. Okay, now let's move on and have you guys try some of these practice problems. Okay, quick reminder that C for water is 4.184. Okay, you would want to use that in this first problem, but not in the second one, because the second one's asking you to calculate specific heat. And then also remember, here is your triangle. You cover up what you're looking for and you perform the rest of the math. At this time, pause the video and attempt these problems. Please check your answers. The first one is just like the one we did on the previous slide. You're calculating Q. So I found my change in temp first. I took 64 minus 31, and then I plugged everything in. Q equals M times C times my change in temp. I only want 2 sig figs because my 31 and my 64 are 2 sig figs, so my answer changes to 56,000. In the bottom question, you're solving for specific heat, which is our C. You're given M, you're given Q, and this time they provided the change in temp. So all you have to do is rearrange the equation or use your triangle, right? If you cover C, you can see the math that's entailed. And then you take the 432 divided by the 5.7 times 14 product. Notice that I placed this in parentheses because you have to do that to get the correct answer. Your specific heat value should never really be all that large. So 5.4, not a huge number. Okay? And that concludes our video lecture on Chapter 3. Please remember to complete your Chapter 3 assignment and bring it to class with you this Wednesday, along with all of your lab materials.